looking at prefixes in this section and looking at the conversion between different units using prefixes. So a prefix is attached to any unit and it either increases or decreases the size of that unit. So if you look first at this table at base units refer to units that do not have prefixes. So for example, meters are the unit for length, seconds for time, and liters for volume. If we add a prefix, any of the prefixes above the base units, we increase the size of that unit. So for example, 1 tera base unit, or 1 terameter, which could be your base unit, or 1 terasecond, or 1 teraliter, that equals 10 to the 12th meters, seconds, or liters. Okay, so by simply adding that capital T, that tera, that prefix, we made that unit 10 to the 12th times larger than it was before. 1 giga base unit, or 1 gigameter, or 1 gigasecond, or 1 gigaliter is 10 to the 9th meters, or seconds, or liters. 1 megameter, or megasecond, or megaliter is 10 to the 6th meters, seconds, or liters. So all of these prefixes make the unit bigger. Kilo is 10 to the 3rd, hecto is 10 to the 2nd, deca is 10 to the 1st, or just 10. Now if you add a prefix that is below those base units, deci, centi, milli, micro, nano, or pico, that makes the unit itself smaller. So 1 decim base unit is 10 to the negative 1st of that base unit. So for example, 1 decimeter equals 10 to the negative 1st meters, or 1 decisecond is 10 to the negative 1st seconds. 1 centimeter is 10 to the negative 2nd meters, or 1 centiliter is 10 to the negative 2nd liters. Okay, so we're going to be using this table extensively, and I will tell you guys in advance the specific prefixes that you need to have memorized versus the ones that you don't, and I'll let you know that in class.
So if I give you 14.2 decameters and I want you to convert it to meters, you're going to follow these 5 steps. The first thing you're going to do is you're going to write your given, which is 14.2 decameters. Then you're going to crisscross swoosh, which is a multiplication sign and then a line, and you're going to write the unit that needs to be canceled in the denominator. So I'm going to crisscross swoosh with that line, and I'm going to put decameters on bottom because I'm trying to get rid of that unit. Then I'm going to put the unit I want to get into up top, which is meters, and then I need to write the conversion factor. Well, there are 10 meters in 1 decameter, and so I'm going to just end up multiplying 14.2 by 10, and that gives me 142 meters, and that's all there is to it. The last concept for this lesson is density. Now, density helps us to relate mass and volume, and the important thing about density is that it can be used to identify substances because every substance has a unique density. So the mathematical equation for density is density equals mass divided by volume. So let's look at an example really quickly. It tells me that the mass of a sample is 562 grams, its volume is 14 milliliters, and it asks for the density. Well, density equals the mass is 562 grams, and the volume is 14 milliliters. And so when I divide, I end up getting 40.143. Well, here's your first opportunity to round based on decimal place. This is your first opportunity to round your final answer. Well, since my final step is dividing, I'm going to be rounding based on significant figures. So 562 has 3 significant figures, 14 has 2 significant figures, so my final answer needs 2. Well, 40, and that's it, it would only have 1 sig fig because I'd be counting from right to left. So the question is, how do I get it so that I'm counting left to right to be able to count that 0? Well, if I add a decimal, 40 point, then that would be 2 sig figs. And so my final answer is going to be 40 grams per mil.